Assalamualaikum. My name is Muhammad Abu Bakar. My roll number is 941470. Today we will discuss gas chromatography. Gas chromatography is a chromatographic technique used for separation of volatile compound. Volatile compound. Volatile compounds are the compound that can easily be vaporized at room temperature. Gas chromatographic components. The column. The column used in gas chromatography is very long or arranged in the coil. The column used in gas chromatography are of two types. Number one, packed column. Number two, capillary column. Packed column. Packed column can be made up of glass, stainless steel. Length of this column vary from 1 to 3 meters and have internal diameter 2 to 4 millimeter. Capillary column. The capillary column is made up of fused cords. These columns are very long and have length from 10 to 100 meters and have internal diameter 0.1 to 1 millimeter. Gas chromatography. The column placed in the chamber so that uniform temperature can be maintained. Gas chromatography stationary phase. The stationary phase is packed in the inner wall of the column. Stationary phase is made by silicone grease wax which can stand at high temperature. The mobile phase. The mobile phase used in usually an inert gas like helium or unreactive gas like nitrogen. The mobile phase gas is kept in the cylinder which is connected with the column or a molecular sieve. The molecular sieve separates unwanted hydrocarbons, water and oxygen. They may interfere in a sample during analysis. The end of the column there is a detector which detects the sample. Let's see the working of gas chromatography. The sample which is to be separated is mixed with appropriate volatile solvent such as heptane, acetone, methanol. Just before the column is a septum that allows injection sample. The temperature of the injection region is 20 to 50 degrees Celsius higher than the column. This allows rapid volatilization of the sample. Once of the sample is volatilized, it is passes down the column where the separation occurs. Gas chromatography separation. During analysis, the temperature of the column is kept between 150 to 300 degrees Celsius. Separation occurs based on the interaction of molecules between mobile phase and stationary phase. The less volatilized molecules interact more with the stationary phase and move slowly, while the more volatile molecules interact more with the mobile phase and move fast down the column. Once a separation is completed, the detection is done with the detector attached end of the column. One of the most common detector FID flame ionization detector. Flame ionization detector has three inlets. One for carries gas which comes from column. and the other two for hydrogen and oxygen. The decided ignite the hydrogen and oxygen produce flame. When the sample molecule reaches the flame, they get ionized and electrons are released across the flame. There are two electrodes, each of the positive and negative charge. The electrodes detect the electron generated by the ionization of sample. Electrons are detected in the form of current, which is amplified and detected by the computer. When the sample is detected, the computer gives a peak with respect to the retention time of the sample. The area on the peak gives information about concentration of sample. If the concentration is less, the area on the peak will be less, and if the concentration is more, the area on the peak will be more. Now for the detection of unknown sample, we need to have standards. Example, suppose methanol is our sample and peak of methanol is obtained 5 minutes, and next acetone is our sample and the peak of acetone is obtained at 3 minutes. Next we run unknown sample and we get this chromatograms. Using information with the standards, we can say analysis of unknown sample, methanol is present and acetone is absent. The remaining peak is still unknown.